Alright, we're going to start part 5 here, and as you can see I got some wiring done. Let me show you. Over here we got the voltage regulator wired in, got all the capacitors wired in, got our Zener diode network, got the filaments. Now, a little note about this wire. This stuff looks thin, but this is actually, these wires are actually number 22 gauge, and they're silver plated, so they have really good conductance. But because of the Teflon coating on them, they have 600 volts of insulation, but they're still very thin and they're very heat resistant. You compare that over here to these wires off this transformer. This is also number 22 wire. You could see 22 and 22, but the difference is this has the regular vinyl insulation on it, which makes it a lot thicker. So don't let the size of the wire deceive you. So we got everything wired up. I wired up the switch, and where I'm at right now is you always want to test your power supplies very slowly. So the first thing I've done is I've plugged my stereo here into the Variac. Sorry, watching the game here. So I have it plugged into the Variac, and I'm going to bring up the voltage very slowly. I do not have a tube put into the rectifier tube socket yet. I don't have any of the tubes in. And the first thing we're going to do is we're going to measure our high voltage and make sure that we have 600 volts roughly. It's going to be unloaded 600 volts, so it may be higher than that, but that's where we should get. I'm also going to check my 5 volt, and I'm going to check my 6.3 volts for filaments. Once I know those are all good, then we're going to apply power. You're going to insert the tube and power up the machine with that, and see what our what our power supply voltage. Now, I like to, when I build an amp, this is how I always do it. I start with the power supply, I wire it, test it, make sure it's working perfectly. Then you move to your next stage, and I build my outputs. So I'll do the 6 BQ5s, the output transformers. I'll wire that all, power it up, and I should be able to run the amp just like that. Now, these two capacitors give DC isolation between this stage of the amplifier and this stage. So what that means is we can actually bring this whole circuit up without this even being built or done yet, and we can actually test it and make sure everything's good with our output stage. Again, this is independent of this because of this capacitor. Okay, the only thing that can pass through here is AC. So by doing that, you're eliminating your variables. If you build out your whole amp and turn it on, power it up, something doesn't work, it can be anywhere. But when you do it one section at a time like this, it's a lot easier to work out the bugs as you go along. Because like I said in the first video, this is a recipe, but it's not going to be perfect. Okay, we may run into some issues, and I want to work them out before I get to the next part. So with that being said, this is the first time I'm turning this on. So I got my power on. I have my Variac up, and I'm at 0 volts. And we're going to start bringing this up slowly. So far so good, huh? So I'm up to about 40 volts. We should have about 600 volts or so on here when we're done. Okay, there's 60 volts, so we're about halfway there, and we got half voltage, so let's bring it all the way up. If you look, there's 120 volts right there, and we got 600 volts. Beauty. Alright, I'm going to drop this down, shut this off. Now we're going to come out and we're going to check our 5 volts. Make sure this is right. Again, normally you would never reach in here like this because of the capacitors if there was a rectifier tube in here. Alright, so we're going to turn this back on, bring it up, and we're just going to put 120 on here right away, and there's your 5 volts. That looks perfect. Okay, turn it off. Let's go over to our 6 volts and see if our 6.3 is on there. Okay, bringing it up. Alright, 6.4, okay. Alright, one last test. We want to check from ground, our ground terminal, to either side of our high voltage. And the reason we're doing that now is we should have our 300 volts on each side. And there we go. There's our 300 on that side. Drop it back down. Check this side. .300 volts there. Okay, so far I would say that our power supply is good and it's wired properly. Now, the next thing I'm going to do off camera is I'm going to go in here and I am going to check all the wiring of each socket and make sure that I have all of the correct wires on all the correct pins. Now, as you noticed, I've twisted my 2 filament wires together, and the reason you do that is twisting them actually cancels out any noise or any hum. This is almost like a form of shielding. So when you twist these wires, you're going to reduce or eliminate any hum that there might be due to the filament windings running around the end. You don't want to give off any hum, any spurious signals in there. So we're doing that. The other thing you notice is I have the same side of each tube tied together. So all the pin 4s go to all the pin 4s. All the pin 5s go to all the pin 5s. Same thing here. Pin 4 goes to pin 4. All of these tubes, pin 4 and 5, is your filament. So I have pin 4, and if you swap 2 of these around, you will be surprised what a horrific hum you can get sometimes because you have your filament windings out of phase. It'll actually cause a hum. So if you ever wire up an amp and you get a big hum right when you power it up, even with just the outputs only, check your filament windings and make sure you don't have 2 of them reversed. Okay, little tip. Alright, so what I'm going to do now is verify all of my sockets are wired properly. Then we're going to put the rectifier tube in, and then we're going to bring it up under power and verify what our DC voltage is, and then safely, we're going to show you how to safely discharge the capacitors and make sure everything's safe. Again, working on this is very dangerous. I know you've heard it on other websites, but when you work with any of this electrical equipment or any mechanical equipment or sharp tools, anything like that, you're doing so at your own risk, okay? If you don't feel comfortable working with these types of things, leave it to someone who is qualified or trained in this or experienced. If you're doing it as a hobby, be careful. Use all the precautions, okay? It doesn't take very much to get electrocuted, and you have to understand there's a lot more power in here than even you might see in a defibrillator or something that they can use to start your heart. This is a lot of current and a lot of power that can release itself all at once, so be careful. Okay, I know I sound like your mother, but I hope so. Truly, you can get hurt. So anyhow, we're going to bring that back up, all that stuff up, and I'll be back. Okay, the gain on this transistor was a lot higher than I calculated. I ended up changing this resistor down here from 56K to 220K, and now it is perfect. Unloaded with no load on the transistor, I have, as you can see, 288 volts, and actually that's just the capacitor right now. I have it turned off, power's off. And with a load on it, even with like a 50K load on there, like a 2 watt load or so, drawing 2 watts on it, it drops right down to 286, which is where it should be. So our regulator's working perfectly, our power supply is working perfectly, and we're now ready to move on and start working on the output section of the amp. So far so good. We have a good power supply. Okay, making a little more progress here. We got the output section wired up. I'll show you here. So all of this back to these is done. So as you can see, I did not have any 68 picofarad capacitors, so I put a 22 and a 47 together, and that's going to give me 69 PF, which is, I think, close enough. And I measured them up on the capacitor checker, and they are coming out surprisingly all similar to around 69 picofarads, so they should be just fine. Got all this wired up, and we're kind of at that point now where we're ready to turn this thing on and put some tubes in it and check and see what our bias looks like. Hopefully this amp should bias up pretty good. Of course it's a cathode bias, but we can take some voltage measurements, make sure everything's wired properly. Of course I'm going to do my customary wiring check, and then we're going to hook up a meter, and we should see some voltages here. Alright, so we're going to measure that up, and we'll be back. Okay, so we've got our meters hooked up, and as you can see here, here's the 2 cathode bias resistors for the left channel, or for the left channel, and the 2 for the right channel. And basically I'm measuring right here on my pin 3, and as you can see, we need to have somewhere around 11 volts of bias. So if everything's working correctly here, we should have bias. Now what I'm going to do is I'm looking just at one of the tubes. I can compare them here in a minute, and I'm also looking at my high voltage. Now remember, high voltage should be somewhere around 320 volts if everything's working properly, and this is the first time under load that we're going to have it. I have my variac turned on and down to minimum, so now we're going to come up. We'll put about 75 volts into this, and we're going to watch our B plus and our bias and see what happens here. See if this thing, see if these tubes even work. Again, we only got 75 volts, so the tube's just going to start conducting now, the rectifier tube. Okay. Very good. Coming up, and look, we're getting some bias. Alright, remember we want it somewhere around 11 when we get max voltage on here. And we'll go up to 90 volts. Okay, so far so good. Alright, let's go up to 120. Right around 120 here. Okay. I would have to say at 120 volts, I wanted 320, there it is, and I wanted 11 volts, and there it is. Okay. I'm going to move the bias over to the next tube and measure that. Alright, very close, very good. Now let's move over to the other side and check the other 2 tubes and see if they're working. Here's number 1. Very good, 11.6. This other one here, 11.6. Okay, so my channels are all working. They're all right around that 11 volt point, and they're all pretty well matched within a tenth or 2/10 of a volt, which tells me that they're biasing properly and that the circuit is working. So now we know we at least have the machine, the tube output section is biasing and is conducting properly. We know our power supply is working properly. I'm going to shut this down now. And I think we're in business. So I think we can proceed on now and start to wire our preamp and driver section. Making pretty good progress. As you can see, I got the preamp and driver section all wired up. A couple of things here. If you look, I have these two resistors and this capacitor, and these two resistors and this capacitor comprise the feedback circuit, which is coming from the output transformer. If you notice, I left the one end disconnected. So if you look over here, this coiled up wire, and over here, this coiled up wire, I'm not hooking up the feedback until we know that the circuit works as is. Adding feedback just creates more issues. So we're going to try this first, make sure it works, and then hook up the feedback. The other thing is, here's our two input capacitors. I did slightly change my design. Decided I don't need this 330 ohm resistor here. Basically, we're given a little bit of a grid leak here on this 1 meg, and since we have capacitor isolation, we never really have to worry about this grounding out and zero biasing the grid here. So the grid voltage isn't going to be an issue because of this capacitor. This cap I added from the original design. So, and I went, instead of a 0.47, I went to a 0.1. I don't think we need a 0.47. I think 0.1 will be just fine. So other than that, we have everything wired up, and although it's, you know, it's point-to-point wiring, it's not a work of art like some people do, but it is properly wired. When you do these things and you wire the two channels up, you try to make mirror images of one another, which is what I did here. And pay attention to the little details. If you notice the little number 2 here, number 2 here, number 1 here, number 1 here, I actually measured these resistors and made sure that they were, I picked the two that were as close matched to one another as I could. Just helps the biasing and helps the amp be a little bit more balanced and perform a little better. So we've got all this wired up, and we're ready to power it up for the first time and see if it oscillates or if it comes up and works. I've gone over and checked all my wiring. Everything seems to be okay, but you never know till that first time you hit the power switch. It's just really hard to tell. So that's what we're going to do. I'm going to get the tubes out, get them in the sockets, bring the thing up slowly on the variac, and see what we get. Okay, emergency update here. These sockets totally suck. Number one, they wick the solder down real bad and plug up the pins, which partially that's my fault, but most of them won't do that. The bigger issue is, here is a 12AU7. This is a standard 9-pin twin triode, garden variety tube. Here is the 6DJ8. Now, in my hand, they look very similar. But if you were to measure the diameter, these tubes are ever so slightly wider than these ones. Now, you may ask me why that would be an issue. And I will say that the little sleeve that these go over, you can see, is ever so slightly too small for this tube to fit in. Therefore, not only were the pinholes gummed up, but this wouldn't fit in the socket. Therefore, I was forced, and you can see my first one's in there, I had to clip the pins off the old socket. Here's, I still have the old one here, I got to do this one, and install these ones, which will fit the tube. I already tested it out, it fits. I am not going to put a shield on these ones. I'm going to leave them unshielded. I doubt that that'll cause much trouble, because this is not a really high gain stage, so I don't think it's an issue. And just causing me a lot of extra work, and all my neat wiring is all messed up, so I got to redress it all. So extra work, and you know, when you're building a one-off amp, these are the things you run into. If I was building 10 of these, the next 9 wouldn't have that problem, because of course we know about it now. But this is what I'm talking about, you know, when we talk about making a recipe. And you know, everybody has a little bit different kitchen, and therefore, and they use a little bit different ingredients, and therefore your cake is not going to turn out the same as the person you got the recipe from. So, good example, but anyhow, kind of frustrating, but oh well. You know, really this project's all about, you know, the fun of taking the time and doing it, so just give me a little more time to work on it. So, anyhow, I thought I'd give you an update and give you a little laugh on that one, and we will be back once I get this done a second time. Well, we're kind of at that good news and bad news thing. The good news is I got the 2 tube sockets replaced, and took care of that and everything. And the more good news is that it pretty much works now. The bad news is it pretty much works. This channel right here works very well, I'll say. Not having any problems. Might need a couple of tweaks. This channel, however, has got some issues. It's picking up some kind of noise or oscillation, and it's very unsymmetrical. And the problem is right at the very beginning here. Now, I don't have any of this in yet. All I have is from here back. And even if I go so far as to just connect my signal generator to this, just the noise of the clip being hooked on there causes this to oscillate. Now, could be a couple things. Could be some wiring problem in here. Could be lead dressing, you know, somewhere where the wires are located, they're interfering. It's not the tube. I tried swapping out the tube. It's not that. Voltages between this channel and the other channel match pretty closely, so I don't think it's that. So we have to do a little more poking around and see what we get. Again, this is still a little work in progress. The other thing I had to do is massive oscillation when I hooked up the feedback lines. And what it turns out is, even though the diagrams for the polarity of the output windings of the transformer showed it one way, I ended up having to reverse them, the plus and the minus. Then everything worked perfectly. My bias voltages came in. The amp does not oscillate anymore. So that part's good. So really we're down to figuring out the noise problem with this. And let me see, I'm not sure if I can demonstrate this or not as we sit, but let's try. I do have my scope connected up. Turn the power on. And right now I'm connected up to my 285 volt regulator right here. And you can see up here, as it warms up, and we're going to be right around 288, 289, something like that, real close to where we need to be. So there you go, 287. And if we look over here at the scope, let me see if I can zoom in on this. Don't mind the little light in the way there. I will connect my little signal wires here. So here's my first one. Okay, and I can turn that on, and you can see perfectly I get my sine wave, no problem. Okay. However, when we grab our other one, now I don't even have this channel turned on yet. I don't even have the output set up on it. But just hooking it up only, and you can see I already have a strange looking oscillation on there. When I turn on the output, really bad. Okay, I'm not getting any kind of output whatsoever. So here, you can see I just get garbage. So that's where we're at right now, and we're going to poke around and figure this out and take it from there. So I'm going to end this right here, and we're going to call this the next part. When we come back for the final part, I'm going to have that troubleshot. We'll go over what I find and what the problem is, and then we'll do a final testing and assembly of this, and then maybe we'll start before the final, then I will have to connect up the input jacks and do the volume control and my little loudness experiment there, loudness circuit. So a couple more, probably we're going to end this part. There'll probably be 2 more parts in the series, and we ought to have an amp that's good to go. So just giving you that, and if you like the series so far, give us a big thumbs up. I always appreciate that, and look forward to seeing you on the next one.